Hi, 7th graders. Today we're going to talk about the real number system. We talked a little bit about the real number system at the beginning of the year, specifically rational numbers. But now that we're talking about square roots, we're also going to start talking about irrational numbers. So as a quick reminder, back at the beginning of the year, we talked about how we have natural numbers. Natural numbers are those counting numbers. So when you're itty bitty, you start counting 1, 2, 3, 4, 5. Okay, those are all going to be counting numbers. Any number that could be simplified to one of those numbers is also going to be considered a natural number. So you can see here I have the square root of perfect squares, the square root of 4, which is a perfect square. That's an example, okay? But the square root of 4 would equal 2, and 2 then again is one of those counting numbers. All of these natural numbers belong also to this whole number category. So we start talking about whole numbers when we have all these counting numbers, and then now we also have the number 0. At the beginning of the year, we talked about integers. Integers are all of these whole numbers. These two boxes fit within the integer category, so all whole numbers, and then now their opposites as well, so like on the opposite side of the number line, so -1, -2, -3, and so on. And then rational numbers, okay, are any number that can be written as a ratio, or basically like a fraction. So it's going to include all integers, whole numbers, and naturals, okay? We could write any one of these as a fraction. Fractions, mixed numbers, and then we have terminating decimals, decimals that come to an end, like -1.5, and then repeating decimals, like 7.16 repeating. So if it repeats in a pattern, it's also considered a rational number. Then we have irrational numbers. Irrational numbers are non-terminating, non-repeating decimals. Okay, so one example, probably the most famous one, is going to be that number pi that we used for area of circles and circumference of circles. But also, we're going to start to see some square roots or cube roots, okay, in that category as well. And so the difference between the square roots that are irrational versus rational are going to be if it's a perfect square or a perfect cube, okay, it's rational. If it's the square root or cube root of a non-perfect square or a non-perfect cube, then those are going to become irrational numbers. So like if we figure out what the square root of 2 is, that's going to eventually give us a non-repeating, non-terminating decimal. So the real number system can be broken into two categories, rational and irrational. Rational numbers are any number that can be written as a ratio or fraction of the two integers, as a over b, where b does not equal 0. And that's going to include all your fractions, mixed numbers, repeating decimals, and terminating decimals. All of these categories are within that rational number category as well. So you're starting at the most specific natural numbers are those counting numbers, beginning with 1, and then now you can say that that's going to include square roots of perfect squares or cube roots of perfect cubes, okay? Whole numbers are all those counting numbers, and then now 0, and integers are whole numbers and their opposites, not fractions or decimals. And then when we get to the rational number category, that's where any other fraction or decimal can be included, terminating decimals and repeating decimals. Those irrational numbers are going to be any number that cannot be written as a ratio of two integers, so decimals that do not terminate, do not have a repeating pattern. It's going to include pi and some non-perfect squares and cubes. All right, that was a little refresher on the real number system. Have a wonderful day.